Welcome to my bar. As we all know, our cells break down carbohydrates to produce the energy it needs to function. This is primarily done through aerobic respiration, with the major stages being glycolysis, the transition stage of the Krebs cycle, and the electron transport chain. However, this cycle requires the presence of oxygen in order to function. And so, what do our cells do when they are in an oxygen deficit? The answer: fermentation. Now, there are two types of fermentation: alcoholic and lactic acid. Only the latter occurs within our cells and starts with the same first stage as aerobic respiration, glycolysis. In this process, glucose is broken down and produces 2 net ATP, 2 pyruvate, and 2 NADH. For glycolysis to continue, the electron carriers must regenerate, and so NADH will react with pyruvate to form lactate, once again becoming NAD plus and returning to glycolysis. This process is much quicker, but much less efficient than aerobic respiration. Now that I have all my safety equipment onto our experiment, it would be quite hard to see lactic acid fermentation, and so we will work with the next best thing: alcohol. Here at my home, we grow grapes, and every year we ferment their juices into wine. But today, I will simply be using a mixture of sugar, water, yeast, in these varying different amounts. Here we have, so this side actually, this will be 60 milliliters of warm water, 0 grams of sugar, and 2 grams of yeast. All of these will have 2 grams of yeast. This is 60 milliliters of warm water with 1 gram of sugar, 60 milliliters of warm water with 3 grams of sugar, 60 milliliters of hot water, scalding hot water, with 1 gram of sugar, and 60 milliliters of ice water with 1 gram of sugar. In alcoholic fermentation, pyruvate is first catabolized into acetaldehyde, and then reacts with NADH to regenerate back into NAD plus and form ethanol. The major difference between this and lactic acid fermentation is the creation of a byproduct, CO2. Because of this, we can use these balloons to measure how well our mixture has reacted as gas pressure increases. Good go. Wait, hold on. And now I will put all this stuff together, and I'll get back to you in an hour. Here are all of the bottles pre-waiting here, all with their balloons attached, and we will give it some time. All right, we are back an hour later, and our balloons have inflated, in some cases and others are not. You may notice that our hot and cold water mixtures have had little reaction. The cold way less than the hot here. A tiny bit, pretty wrinkly. These ones are much more full, much more firm here. The are two more warm water with sugar, of course. This is because most proteins and enzymes operate best at certain temperatures and can even be destroyed or denatured at high enough levels. In our zero sugar bottle here, there was no reaction. This is pretty much just our control. There's no glucose here to fuel glycolysis, so there is no CO2. As you can see, both our warm water containers with sugar have had a good reaction. However, well, what was supposed to happen was that this one was should have been bigger. Perhaps I may have messed with the measurements wrong, or I mixed up the bottles. But generally speaking, the higher concentration of reactants in a mixture, the faster the reaction will occur. And so typically you would see that this balloon would be smaller than this balloon, but I may have just made a mistake here. And that's pretty much it. I'll be using the active yeast containers. I'll be keeping the yeast containers alive and fed, and I'll be using them to make some mead in the near future. Thanks for watching.